Welcome to Module 1 of our course Indoor Environment and Building. In this first module, we will build a foundation of understanding around safety, health, air quality, and comfort inside buildings. We begin with safety and health. Every building, whether it is a family home, an office tower, a hospital, or a factory, is ultimately built for people. Safety and health, therefore, are the most important concerns of indoor environmental science. Think for a moment about how much time people spend indoors. Research shows it can be up to 90% of our lives. That means the conditions inside buildings, air, light, sound, and temperature, directly shape human health and productivity. When indoor environments are unsafe, the results can be serious. Poor air quality may cause headaches, fatigue, or long-term respiratory illnesses. Uncontrolled noise can increase stress and impair concentration. Bad lighting may harm vision and disrupt sleep cycles. Thermal discomfort may reduce performance and create chronic health problems. Safety also involves protecting occupants from accidents such as slips, exposure to harmful chemicals, or fire. Building designers must consider not just structural strength, but also fire safety, smoke control, and safe escape routes. So when we talk about a healthy indoor environment, we are talking about much more than comfort. We are talking about life safety, health protection, and productivity. Lecture 2: Indoor Air Quality and Thermal Comfort. Now, let us move to two of the most critical aspects: indoor air quality, often called IQ, and thermal comfort. Indoor air quality refers to how clean or polluted the air is inside a building. Poor air quality can result from many factors: insufficient ventilation, emissions from building materials, pollutants from outdoor sources, and even human activity such as cooking or smoking. One common issue is the buildup of carbon dioxide in poorly ventilated rooms. Although not directly toxic at low levels, high concentrations make people drowsy and impair their decision-making. Volatile organic compounds, or VOCs, released from paints, adhesives, and furniture, can irritate eyes and lungs. Biological contaminants, such as mold spores, dust mites, or bacteria, may trigger asthma and allergies. On the other hand, thermal comfort describes how comfortable a person feels in relation to temperature and humidity. Comfort depends on 6 main factors. 4 of these are environmental: air temperature, radiant heat from surrounding surfaces, air movement, and humidity. The other 2 are personal: the clothing a person wears, and their level of physical activity. For example, an office worker in light clothing may feel comfortable at 23 degrees Celsius, but a construction worker in heavy protective gear might feel overheated at the same temperature. In practice, designers must strike a balance, ensuring both fresh, clean air and temperatures that most people find comfortable. Achieving this balance requires careful design of ventilation, insulation, and air conditioning systems. Lecture 3: EU and Norwegian Standards for Indoor Air and Comfort. Designing safe and comfortable environments requires clear rules. This is where standards and regulations come in. Within the European Union, workplace health and safety is governed by directives such as the Framework Directive 89/391/EC, which obliges employers to provide a safe working environment. This includes proper ventilation, adequate temperature, and control of harmful substances. Specific standards also exist. For example, EN 15251 provides guidelines for indoor environmental input parameters for building design. It defines acceptable ranges for temperature, humidity, airspeed, and CO2 levels. Another is ISO 7730, which uses the predicted mean vote, PMV, and predicted percentage of dissatisfied, PPD, indices to evaluate thermal comfort. Norway, as part of the European Economic Area, applies these EU rules but also has its own national laws. The Norwegian Working Environment Act specifies that workers must have access to fresh air, appropriate lighting, and an acceptable indoor climate. The Norwegian Labour Inspection Authority issues detailed regulations covering noise, radiation, and ventilation. Why do these standards matter? because they create a benchmark for design and evaluation. An engineer can design a ventilation system knowing exactly how much fresh air must be supplied per person. A facility manager can measure CO2 or humidity and compare them against the standard to judge compliance. Without these standards, indoor comfort and health would be left to guesswork. Lecture 4: Dry air, humid air, and moisture problems. Air humidity is often overlooked, but it plays a key role in both comfort and building durability. Dry air, typically defined as relative humidity below 30%, can cause sore throats, dry eyes, and cracked skin. It also dries out mucous membranes, making people more vulnerable to infections like colds and flu. On the other hand, humid air, above 60% relative humidity, creates perfect conditions for mold growth and dust mites. These are major triggers of asthma and allergies. High humidity also damages building materials, wooden floors warp, paint peels, and condensation can rot window frames. Moisture problems are among the most frequent building failures. Condensation often forms on cold surfaces, especially around poorly insulated windows or thermal bridges in walls. Roof leaks and plumbing failures can also introduce moisture that leads to hidden mold infestations. The ideal indoor humidity range is generally between 40 and 60%. Within this zone, occupants are comfortable, infection risks are reduced, and the building fabric is protected. Maintaining this balance requires good ventilation design and sometimes the use of humidifiers or dehumidifiers. Lecture 5: Design specifications for thermal and atmospheric environment. When designing a building, engineers must establish design specifications, target conditions for the indoor climate that will ensure both comfort and safety. For the thermal environment, specifications typically include acceptable temperature ranges for summer and winter, maximum air velocity to avoid draft, relative humidity limits, radiant temperature from walls, floors, and ceilings. For example, offices in temperate climates may specify 20 to 24 degrees Celsius in winter and 23 to 26 in summer. Air velocity should be below 0.2 meters per second for sedentary occupants. For the atmospheric environment, specifications focus on air quality. Oxygen concentration must remain near 21%. Carbon dioxide should not exceed 1,000 parts per million in occupied spaces. Concentrations of pollutants such as formaldehyde and benzene must stay below established health limits. Odor levels should be low enough that they do not distract or disturb occupants. By writing these specifications into design documents, architects and engineers create measurable goals that can later be tested and verified. Lecture 6: Acoustic environment and actinic environment. Now, let us consider two additional but equally important aspects of indoor environment: sound and light. The acoustic environment has a profound effect on human comfort and performance. Excessive noise can lead to stress, reduce concentration, and even damage hearing. In offices, noise reduces productivity. In schools, it interferes with learning. Good acoustic design aims to control background noise, reduce echoes through sound absorption, and insulate walls to prevent noise transfer between rooms. Meanwhile, the actinic environment refers to the effects of light and radiation on occupants. Natural daylight is essential for regulating circadian rhythms, improving mood, and enhancing productivity. Poor lighting, whether too dim or too harsh, can cause headaches and fatigue. There are also safety considerations. Certain workplaces expose people to ultraviolet radiation, lasers, or welding arcs, which can damage eyes and skin. In such cases, protective equipment and shielding are required. In short, a building must not only provide fresh air and stable temperatures, it must also offer quiet spaces and healthy light conditions. Lecture 7: Summary of Module 1. As we close this first module, let us review the key points. Safety and health are the foundation of building design. Indoor environments directly affect well-being and productivity. Indoor air quality depends on controlling pollutants and supplying fresh air. Thermal comfort relies on balancing temperature, humidity, air movement, and personal factors. European and Norwegian standards provide clear benchmarks for indoor air and comfort, ensuring protection for workers and building occupants. Dry air and humid air both create problems. The healthy range lies between 40 and 60% humidity. Design specifications for thermal and atmospheric conditions guide engineers in achieving measurable comfort and safety. Finally, acoustic and actinic environments, sound and light, are essential to complete the picture of a healthy indoor environment. This foundation sets the stage for Module 2, where we will explore ventilation, air conditioning, smoke control, and practical strategies for evaluating and improving indoor environments.